I didn't do any practicing. You'll have to bear with me. All right. Hi, everybody. My name is Kalika qary. I am an intern at Tangible AI, and I am here to share with you my experience in building the life coach chatbot. So, what is the secret to happiness? All right. So, you got to face it. There isn't one really. But a lot of times we can find a resolution through some self-reflection, and it can actually help to talk it through with someone. So Burns had an interesting approach, which involved looking at an event that's disturbing you, and you kind of eke it out in this notebook. And from there, you just self-reflect on what's negative. And then you kind of go back and identify, okay, I distorted it, I blew it way out of proportion somehow. And now we're going to figure out what's really going on with me. And that is where the chatbot comes in. So we took a look at his daily log, mood log, and we pulled this into this sort of chatbot. And I'm just going to scroll down really quick here to our little, I don't know what you call this, flow chart of what this chatbot does, which is kind of looks at the event, says, okay, something went on. We're going to recognize your negative emotion. We're going to prompt you for a rating. And then we get into this sort of, what's the distortion? This cognitive distortion that we know that's going on there. And then you're going to re-rate that. And then we're going to look at your emotional status and see if there's an improvement or not. Okay. And so now we can do a quick demo of it. And here we have describe an upsetting event. Does anybody have like an upsetting event they'd like to describe? Ryan, how about you?
Yeah, for me, I think on Saturday I had a flat tire. That wasn't too fun.
Saturday, I had a flat tire and that wasn't too fun. Oh, well, how did that make you feel?
I was kind of scared and pretty upset in the moment.
Okay. So on a scale of 0 being the least and 100 the highest, how would you rate this feeling? How negative did that make you feel?
Maybe like a 15.
Okay.
If that's pretty negative.
15. We can go with the 15. So which distortion would you say this would fall under? Where you look, and there's a lot on this screen, so maybe I can I blow this up a little? Can you see that better?
Yeah. Let me take a second to read over these. Sorry.
Oh, it's all right.
Kalika is going to add a feature to perform the sort of education that happens in the Burns book to get these sort of ideas in your head so you don't have to think about them every time. And so it'll become more habit. That's the whole advantage of this approach.
Got you. Let's go with filtering for now. Mental filter, you dwell on negatives and ignore the positive. That's how I felt in the moment.
Awesome.
Great. So now that we've recognized the distortion, how do you think you feel on a scale of 0 to 100? 100 being like most intense.
What do you mean by that? Like feel now that I've understood what was wrong, or when am I? Oh, I feel like maybe like towards an 80. I guess I've never taken the time to sit there and reflect on having a flat tire, getting towed and all that. So I guess it feels good. That's like some good is coming out of that.
Okay, so we put down an 80. How do you feel now?
Better. I mean, I think the fact that made it to this talk is some good in the situation. So feel better. I got to like think about it too.
Okay, is there anything else that you're feeling?
Not so much.
All right. Congratulations. You just completed
that was an awesome first experience. I got to reflect on not a great situation. I'm glad that helped out a little. So I like it. I would do it again.
Oh, great.
Awesome.
I'm glad to hear it. It's awesome. Yeah. So unless anybody wants to go again.
It looks great.
All right.
You can ask the audience for questions or feedback or ideas.
Oh, yeah. Yeah. Is there any questions, feedback, ideas?
Wow.
Okay.
I don't think I have any questions, but that was just really neat. That was awesome.
Same. Enjoyed it.
One question that an audience, somebody might ask is, how did you implement this? Did you have to code up a bunch of Python if-then statements? How did you create this bot?
Oh, yeah. It was just a YAML file.
Right. And
right. It was a YAML file. And then I worked also with Tangible AI, Hobson mostly, to get some NLP going in the background to do some of that fuzzy sort of keyword recognition to sort of understand what the user is saying. There is some Python involved, or quite a bit of Python involved, actually. But on my part, I don't think I had to do too much coding. Did I do a lot of coding, Hobson? I forgot.
A lot of debugging, a lot of pointing out bugs to me and helping me fix them.
Yeah, I'm good at that though.
So this is all within the query frameworks. This is now a skill within query, and Vish is working on deploying it to a web application. So,
cool.
Awesome.
Yeah. Cool.
Who's next?
I'll stop sharing.
I can go next.
Awesome. Martha's going to talk to us about her model. She was originally working on a project for book club question generation, and in order to build the foundation for that, she's built a multi-label classifier, and she taught me a lot about how those things work, and she's going to teach us again.
Okay, so here's my project on multi-label book genre classification. So my problem statement, the aim of my project was to build a machine learning model that'll determine the genre of a book based on its summary and or title. So this I envision can be helpful for maybe a recommender system where we have a user that's looking for a book based on a genre of their liking, or Hobson mentioned something really cool, maybe for authors or publishers who want to make sure that their synopsis or their book title is in line with their target audience. So this will make the book just more enticing and obviously easier to find for people that are looking for books of that genre. Here's just a little snippet of the data set that I used. I'll talk more about that in a second. So the data itself was from the Carnegie Mellon University book summary data set. It had about a little over 16,000 books that were extracted from Wikipedia. It had some metadata like publication date and things like that. But what I focused on was the book title, the genre, obviously, and then the plot summary. Originally, there were 215 total genres that I was able to extract, but I found that for some genres, it only had one book associated with it. So I wanted to reduce my genres down to 55, which includes all genres that have at least 20 books associated with it. So as we see here, these are the 55 genres. It's a very imbalanced data set for the purposes of this project, and this is my very first machine learning project. I decided to work with this. But for future work, I think definitely having a more balanced data set would be beneficial. Here on the right, I have the labels per genre. So many of the books had only one genre associated with it, but in some instances they had up to 10 or 11. So we see that here on the right. For pre-processing and feature creation, so I am currently a graduate student in a computational linguistics master's program. And one of the main things that we are always taught is that you always have to clean your data. You have to get rid of stop words, you have to get rid of punctuation, you have to do all these sorts of things. After discussing these things with Hobson, I decided to limit that. I basically just lowercased my text and stemmed the words. So words like, for example, killed, killing, killer, they'll all be reduced down to kill. So just reduces our data a bit. I did create some features for the plot summary. This included things like character counts, word density, and I also wanted to experiment with some sentiment analysis. So using the Vader sentiment Python package, I was able to get the positive, negative, neutral sentiments, as well as a compound score, which is just the sum of all those three. And in addition to that, I also created some spacey vectors for the book titles. As far as text transformation for the actual plot, when I wasn't using these extra features, I used TF-IDF as well as count vectorizers to kind of just transform my text to be able to be input into a machine learning model. So for my problem transformation, now this problem is a multi-label classification problem. Anything that I've kind of worked on or read has always been binary classification. So for this, we wanted to I turned this into a binary relevance problem, which treats each label as a separate single class classification. So here, what I did, here on the right, I have a multi-label binarizer, which created 55 target variables, which is for each of the 55 genres in my data set. To implement this within a model, I found this classifier called one versus rest classifier. It works kind of like a wrap so that I'm able to implement logistic regression, the stochastic gradient descent, I believe it's called, and the linear SVC for my models. And here's just an example of one of the models and how the one versus rest classifier kind of wraps that model. So I did a few experiments. I didn't include all of them here, but here's my hyperparameter table. So the data that I used was the original summary. I wanted to experiment with the clean summary where I did remove some stop words just to kind of experiment and see how that affected the accuracy. Then I also have my numerical features, which are like the word counts and character counts and all those extra features that I created, as well as my spacey vectors. So as we see here, my test scores are pretty low. And so we realize that this is because usually when you're training like a binary model, these are the metrics that you use. But in this case, let's say a book has 3 genres. If my model were to correctly predict 2 out of the 3, it would still come up as incorrectly classified. So I took the Hamming loss into consideration, which is the ratio of the incorrectly predicted labels over all of the or all of the instances of labels, as well as kind of the inverse of that, which is the ratio of the correctly predicted labels over all of the instances of labels. So I did get a pretty good accuracy of 96% with a pretty low Hamming loss. Some of the things that I learned about the hyperparameters were that the model did perform the best on the original summary. So this kind of debunks the idea that you do have to do all of this cleaning of your data prior to modeling. Stop word removal did score pretty okay, but even without removing the stop words, my model did well. Working with just the summary alone was powerful on its own. As you see here, like the features I created and the spacey vectors, they didn't really score that well. Changes to n-gram ranges, as we see over here, did not help with the accuracy, and the numerical features that I created alone didn't prove useful within our model. When I added them in conjunction with the TF-IDF vectors, it performed a little bit better, but overall, through all of my tuning and experiments, I did find that just working with the summary alone did pretty well. So for future working conclusions, so further cleaning of the genres, Hobson and I talked about using word embeddings to word embeddings and as well as clustering to kind of group genres closer together that may improve the accuracy on the models. I did want to explore more with different hyperparameters for each classifier. I know for SGD, there's like different loss functions and things like that. I'd like to explore different features that I can create outside of the ones that I use. Those are pretty simple, but they didn't really work well for this model. Maybe exploring some deep learning models such as CNNs or RNNs may help the model work a little bit better. And I'd like to create better visualizations for my data. I found that because it was multi-label, I wasn't exactly sure how to kind of produce these representations that really accurately display kind of what I wanted to show with how each genre is different from the other. And then because I used binary relevance for the problem transformation, I'd like to work with maybe classifier chains or label power sets and see how that works. And then as Hobson mentioned, my original idea was to create a system that will automatically generate book club discussion questions based on a summary. So maybe using this as a base where we can predict the genre and then have kind of some sample questions that go along with each genre. It can help in creating that kind of model. And so here, really quick, here is just the F1 scores. So because this is multi-label, the F1 score that I use, which is the micro F1 score, kind of took the mean of all of the F1 scores for each genre. So as we see here, like a drama book didn't score pretty well, and none of these scored well, but a lot of these are very popular genres that people like. So further exploration into my model to see maybe there weren't enough instances of these books or these genres. So again, expanding on my data set, making sure that it's more balanced will help with that. And then lastly, I just wanted to do a test run. So this is just a random selection where I have a book, my predicted genres, which kind of match. So these, I got lucky on this test run where I had a lot of good matches here. But I definitely learned a lot. As I said, this was my first machine learning model and things make a lot more sense. So I'm very happy to have done this, and I feel like I definitely learned a lot.
Awesome, Martha. Questions? Ideas?
I just wanted to say good job. I've walked some people through really similar projects with like multi-label classification, also based on summaries. And I think every like step of the way that you took, everything that you tried, like feature engineering, all that stuff, literally like the perfect process, like amazing route you took step by step. And then taking it like a step further with everything you had plans with like looking at more plots and stuff. That's like the perfect route to go. It's like a really solid project.
Oh, great. Thank you.
Awesome. Anybody else? I guess we have to keep moving. Thank you so much, Martha. Who's next?
I think I'm next. I don't know if my audio is working today. Can you guys hear me correct?
Yeah, it's great. No echo this time.
Let me just share my screen. Oh. Okay. Let me. Okay. Hi guys. My name is Makara, and I did my project on. I did racist tweet detection. So the objective of my project is to build a classifier that can identify whether a tweet contains racist language or some sort of racist slur. Actually, I ended up having to switch my data set to a bigger data set because some of my results were not coming out right. Like my confusion matrix was basically classifying everything as non-racist, which it's not much of a detector in that case. So when I switched over to doing just a general hate speech detection data set that I was able to find that was labeled, it has 3,000 data sets. It has 3,000 tweets in there that are classified that have a binary classification similar to the one I was working with, but much bigger. So it's not exactly a racist tweet detection, but it's more of a general hate speech detection model. So, and my motivation behind this is over the past few years, with the growth of social media and just more cyber interactions, there's been a huge increase in cyberbullying and also the use of hate speech on social media platforms, especially on Twitter being the third most used social media. It definitely, we've seen through COVID, through a lot of the Black Lives Matter movements, that there's been an increase in hate speech on Twitter. So I guess my motivation behind is to just be able to filter out some of that negative energy, so we can focus on a more positive feed, I guess. So yeah, I guess I briefly mentioned this. For my data, I initially was working with a data set that I basically hand selected, and it was supposed to have 9 tweets that were classified as racist, and the rest would be just ordinary tweets. But just to have a more balanced data, I was able to find a data set that was labeled with 90, well, I guess the way it would split up is 91% of it didn't have any hate speech, and 9% of that data did. And when I split up my data, data for testing, I did 70% for training and 30% for my test. Actually, but then 9%, it's, when I calculated it, actually ended up being 8.8% for the ones that are labeled with hate speech. But there's a more descriptive graph on the page right here. Okay. And for my data cleaning, I initially started out with, so I've cleaned the data for from any specific characters, such as double quotes or punctuations, and any pronouns. I kept things like the emojis and @ symbol, just because I figured, actually we talked about this with Hudson during one of our sessions. We didn't want to do too much cleaning up with the data, just so it doesn't alter the meaning. So yeah, I kept a lot of, I kept the emojis and some of the symbols, but I did get rid of some pronouns. Also, for tokenization, oh yeah, and I did tokenization just to process the text. I needed to split it up into smaller chunks, and here I've split up the sentences into words using the word function tokenizer, which is in the, I believe it was, yeah, it was using the NLTK library.
Awesome.
Oh. Okay. And for my future engineering, I used bag of words. It's based on the word count statistics, and I also used the extension of bag of words, which is bag of n, the bag of n-grams, and I tried to limit that to 3, just because I know that's it could be computational. It can have like a high computational cost. So I tried to limit what I used for that. And for my modeling, for my hyperparameter tuning, I used a range of C values to iterate over the range. To iterate over that range to be able to identify the best C value. I initially started off with just playing around with 0.1, 0.5, 1, and 2, and I saw that as it got bigger, it would converge to a certain value. So I figured it would be really cool to just give that a range and just be able to do an iteration and find the best C value. Actually, there's a graph here that shows a better picture of that. Okay, somehow my left key is not working, so I'm like swirling with my mouse. Sorry. Yeah, so here is the plot that shows the iteration over the range of the oh, I didn't put the code here. Okay, but yeah, so here's the plot that shows the iteration over from the 0 to 100 C values, and we could see that the best value ended up being 81, so like somewhere around here. So that was the C value that I used in my logistic regression, which is part of the code I showed earlier, but it's also right here. Yeah. So yeah, I used a logistic regression, and yeah. Okay, and as for my results, these are my validation results, and you can see that it's doing really well on the confusion matrix. That, like I mentioned earlier, that wasn't necessarily the case when I was using a much smaller data set. So no false positives or no false negatives. And next is my validation results, and you can see that it's also it's doing really well, that it minimizes the false positives, but the false negatives are still a bit of a challenge. I haven't found a way to reduce that yet. Yeah, and finally, I have the result in terms of precision, recall, and F1, the F1 score. And you can see that the model, so it does really well on with the high precision, and it doesn't do too well with the recall. And I think this is due to the imbalance in my data, and yeah, I think this my data still might have some imbalance to it, but I also think it's mainly due to not having enough of the low size of the negative tweets, and I once I do find a much bigger data set, or actually I was thinking of maybe using a random forest to I guess for future works, I do want to try to use a random forest to kind of give myself a larger data set. I know like it works. Random forest tends to work better, tends to help small data sets kind of do well within getting like a better accuracy. So yeah, that was my project.
Awesome work. You've done so much in the week since you were struggling with that limited data set that you had early on.
Yeah,
I'm so impressed.
Thank you. It wasn't yeah, after that confusion matrix, I realized I had to do, I tried to fix that. I tried to do a lot of reading on it, and I realized the problem just might be my data set and what I was using. So I decided to like look for a more like a bigger data set, and this actually happened to work. So thank you.
And Ryan mentioned some other sources of data that I failed to mention early on in this project. So you did awesome.
Thank you.
Yeah, I love the topic. I think that in real life, we tend to wind up with imbalanced data sets. So there's actually a lot of reading, a lot of approaches. I don't know if you like looked at using class weights or something like that, but
I actually I haven't looked into that yet, but I'll definitely check that out. You said using class weights?
Class weights, yes, that's one approach. Old-fashioned, people did rebalancing and things, but there's whole things you can read about this, and I wish it were a less common problem, but unfortunately, most of the interesting problems we work on, is this cancer? Well, actually, most of the time it's not, thankfully. But so it makes it hard to get a really good detector because, yeah, you either you predict everything's not cancer because that's the majority, or else it's really hard to get the false positives, false negatives right.
Yeah, definitely agree with that. It was a bit of a struggle, but yeah, well, definitely I would love to keep working on this. It was a really good experience.
Awesome. Can we move right along just so we can get through this and everybody gets a chance? So who's next?
I think I'm next.
Great, go Greg. Looking forward to hearing your project.
Okay. Can you all hear me okay? Okay, thank you. So my name's Greg Thompson, and I'm an educational technologist who's completing the internship with Tangible AI, and I've done a couple projects, and I'm just going to talk to you about what they are and what I've learned from them. So I came to the internship with a little bit of background in conversational design, but I was a bit concerned because I wondered how I could design good conversational experiences if I didn't really understand the technology behind them. I didn't really understand how a chatbot worked or what was going on underneath it. And so I wanted to explore both design and development. I wanted to see how they related and how they differed, how they could support each other, and how I could kind of use some development knowledge to improve my design ability. So one project that I worked on for most of the internship was Cindy. Cindy is a chatbot that helps people dealing with feelings of imposter syndrome. And I developed a conversation flow to help people reframe their perspective on things they might have viewed negatively and maybe find some positive point to focus on. After designing that, Maria and I created triggers for event analytics so that we could make sure that we knew where users were moving through the conversational experience. And then I wrote test sets to help make sure that the flows were working as we intended and that the analytic triggers that we made were working as well. And that was all in preparation for user testing, which is still ongoing. So there's more work to do there. But as I was designing the conversation flow for Cindy, I wanted to reuse a value from one form in a later form, and my design really hinged on that. I thought that that was a better approach, and so I designed it. But when I actually went to implement it in the platform we were using, the platform did not have the ability to use default values, reuse variables in a default value. So my design didn't work. And so I kind of ran into that problem again, like without understanding the platform and without understanding how development actually worked, my design kind of suffered. So I had to redo the design around that. And so I really thought it'd be great to explore different platforms so that I could get more intuition around this. So I worked in Rasa and Mycroft and Dialogflow. to develop just some simple test bots. Sorry, I don't know why that happened. Right. With Rasa, I developed a quiz bot, and it had some features. You could choose the difficulty level of the quiz that you would like. It provides a score after going through the quiz, and it offered some general feedback about how you might want to study further. While I did try to design a good bot, my main focus was on using a lot of features of Rasa so that I could understand, what was going on and what these kind of pieces of Rasa were. And I even tried to integrate them, integrate the chatbot with other services as well. So you can see a list of things that I worked on here. The next type of chatbot that I worked on was Mycroft. Mycroft is an open source virtual assistant, and it's still a work in progress. I couldn't get very far with this because of the other projects. I basically just set it up on a Raspberry Pi and made a test skill. But what I'm hoping to do is develop a voice assistant that will tell you stories upon request, and stories that I've made for my daughter. Yeah. And the final chatbot that I worked on was in Dialogflow, and it's a problem discussion bot. As a teacher, I teach a unit on problem solving, and I wanted students to focus on actually discussing the problem. So by talking with this chatbot, hopefully it would allow them to practice talking about the problem itself in a problem solving discussion. And they would do that by asking questions. So it would help them practice question grammar and thinking of ways of deepening the conversation instead of just asking a bunch of random questions. And my kind of hope for this is that I'll have two different bots that offer two different perspectives on the same problem, and different students would interact with different bots so that they would get different perspectives, and then they would talk to each other and have to reconcile those differences and then talk about solutions. So this is a common activity called an info gap, but the kind of new thing here is that with most info gap activities, you give the student a paper, they kind of memorize it and read it and then use that information. But in this way, they're kind of actively constructing the info that they're going to use to talk with their peer. And I worked with these platforms. I learned a lot from them. The bots that I've developed are still works in progress, but they were good. But I still didn't really understand how they were working, like what was going on even deeper. And I wanted to know just a little bit more. So I did some work in qary as well, just very simple Python work, writing debugging code or adding a parameter and moving functions between files. My Python skills are not very great, but by doing these kind of tasks, I got some intuition for how models integrated into skills and how skills were working. And I kind of got a little bit deeper understanding of how the chatbots worked. So to go back to the original question, design and development are both important. They have different skill sets or different things that they might focus on. Like with design, we might focus on Grice's maxims. With development, we might focus on the architecture and the best way to actually implement something. But they also complement each other very well. As a designer, knowing about development can help me come up with better designs in line with platforms I'm working on. It can help me ask questions to developers so that I understand the platform better and I can work with it. Yeah, and I learned also that trying out different tools broadens your perspective. I tried out these tools, and then through kind of the weekly chatbot meeting that Tangible AI has, we always try out different tools, and I noticed that many tools bring a different perspective to how conversation design works or should work. And so that gave me some ideas for how I could work in conversation design. And throughout this process, I encountered many, many problems and had to pour through documentation and all that kind of stuff to work through issues. But I found that problems invite you to reframe your perspective. Many times I got stuck on something and it was because I kept thinking a certain way. But when I took a step back and kind of reframed my perspective or learned a little bit more, reread some things, then I could work through my issue. And it also indicated areas of potential growth where I could explore more and become better at whatever task I was doing. So that's it for me. Thank you. It was a great internship opportunity.
Thank you, Greg. You were such a big help. You helped us push the technology forward in areas that we didn't think we would ever have time to try out all those different platforms, and you did it for us all in a few months, in a couple months. Really amazing. Looks like Becky had a question about whether you were able to try anything new with Cindy besides being stuck with, I think it was MiniChat or whatever, or Landbot. Did you get to try anything else besides that platform that was so problematic?
We didn't try anything with Landbot yet. We've talked about maybe implementing it in Rasa, but we haven't really moved forward on that. Yeah.
Awesome. Future work.
Future work.
Anyone else? Questions?
Good job.
Thank you.
Yeah, really amazing. Who's next?
I'm next.
Excellent.
Yeah.
Go for it, Kazuma.
I'll share my screen. Okay. Can everyone hear me? Yeah. So I'm Kazuma. I'm a junior at a college. I'm a college student. And this summer I did a project on Robust NLP. Okay, so what is Robust NLP? Why was I interested in it? And why should you care? So I'm new to machine learning. This is like my first year, like getting really deep into it. And I learned that current NLP systems are actually pretty good when tested against benchmark data sets. They perform well. Like some of them have like most of the tasks have over 90% accuracy. But I also learned that when the inputs are perturbed or they come in an unexpected form, they don't perform well as they say they would on benchmark data sets. And that I thought was a big problem. And even in this project, I was able to bring down the model accuracy by 50% by substituting synonyms. And considering that the real world around these models are changing, it's like even in just language, it evolves over time. The context talked about and like frequencies of words used, they just change. And in this world, like you need to expect the unexpected, and for these models to not handle the unexpectedness, and I thought that was a problem. So I looked into this project, and I thought this meme you see on the right was funny, because when I came into machine learning, I thought it was like going to destroy the world and everything, but it really is far from it. So yeah, the experimental setup was I used a fake news prediction problem as the toy data problem. And I really had two main objectives of this project. One was to measure NLP robustness, and the second one being what makes these models more robust. I dealt with the data leakage that I got from Kaggle, because without it, then the model would rely too heavily on the data sets to predict. And especially because the data was picked from a year when Trump and Clinton was having an election, like it would be bad to rely too heavily on a data set, because then it would just specialize, you know, distinction between the fake and real during that time, not really robust in not in like a general sense. And that's what we were going for. And in order for us to measure robustness, we needed a synonym substitution to like make us a new example or new perturbed example. And the goal here was to achieve label preserving perturbation, which is decreasing the machine accuracy while maintaining human accuracy. And that was important because it's not feasible to expect the machine to predict something accurately when a human can't, at least not yet. And we used random search algorithm to find the best hyperparameter for the synonym substitution. The synonym substitution went like this. There's an input, and there are certain words for that could be substituted with. And this function went through each words and the confidence of the model to predict it as an accurate one. And it picked the word that reduced the confidence of the model the most. So this was one of the examples. And this is the model. I mean, this is the results that I got. And I think it's important to look at 3 different variables and how they affect the robustness like separately. And one of the biggest one that I found that was like really effective was the feature engineering methods. So we looked at TF-IDF, which calculates the relevancy of a word, and we used Spacey and Espert, which used word embeddings from pre-trained models. So we can see here that TF-IDF performed worse than Spacey and Espert. And I think that was because Spacey and Espert were able to use the whole sentence to extract meaning out of it, but TF-IDF could only look at individual words, so they couldn't take into account the whole sentence. So I think there were some information lost there. So some like context or intention or like just simple nuances in the sentence level structure. So we think that was a big one. Other difference was I tested it on different TF-IDF hyperparameters. So that's seen in the red line here. The higher min-df meant decreased the Spacey, decreased the vectorization size. So it considered less data set to consider. So it was less reliant on the data set than if it was like a lower min-df, because then that would consider all the words. And so even within Espert and Spacey, there are different pre-trained models, and the one with higher dimensions and bigger size tended to perform better, but that came at a cost of slower training and more memory needed to be stored. That was the results summarized. And what did I learn? So I learned like intuition on which hyperparameter to use, and I'm able to test and measure ideas. But I think the most important thing I learned was that robustness is an important model quality measurement to consider alongside other measurements such as, test and train accuracy and memory and the training speed. And I think by considering robustness, we can achieve a fairer model, and hopefully like further research could be done, like as Makeda was suggesting, like about racial slurs, and there's a lot of differences within cultures, and the models probably perform differently to, let's say, the majority versus the minority because of the data imbalance and everything. So I think further research should be done to consider like robustness across different cultural backgrounds. So yeah.
Amazing, amazing, amazing. You've gone from 0 to hero in just 2 months. Really, really amazing how far you've come in terms of you're doing research that I wish I had the time to do. You're learning things that I wish I had the time to learn. Really amazing. Robust NLP is a really cutting edge field right now.
Yeah, Thank you.
Any questions? Yes, Becky says we should submit a paper, and yeah, we're thinking about doing that. We're going to first try some blog posts and on Substack, and then we'll or Kazuma will, and then we'll see where we go from there. We'll see if we can put together a good academic paper out of it. Just
Yeah,
help
cool.
others build on it. Like so most of these ideas came from that Robust NLP thesis by Robin Gia, I think it was.
Yeah.
I don't know if you mentioned him, but that's where this concept and a podcast by in an interview with him. Awesome. Any other questions? Okay, I think we have Connie. Are you next?
Yes, I'm next. Hi, everyone.
Excellent. Connie has been through a lot these past 2 months. Not only has she gone through the ringer with me, trying to fill her brain with Python and machine learning skills, but she has also contracted COVID, and she and her daughter were home alone dealing with that horrific horror, and she survived, and she was able to put together a report for in only a week or two that she had after she recovered. Really amazing. But go for it, Connie.
Thanks, House. Hi, everyone. Just to give you a brief background about myself, really, I'm from a non-technical background. I have a background in finance and just been working as a business analyst for a chatbot for an ad tech. I'm sorry, my throat really. Can you hear me properly? Okay, that's fine. So like Greg mentioned, I've been in conversation design, but then the frustration was that I wanted to understand what was happening behind. And when I saw an advert by Marie, I think sometime in March, on one of the conversation design groups, I kind of just jumped on the chance for doing the chatbot internship. So I really learned a lot. Just this is a summary of what I've learned, just lessons learned. If I had more time, project proposal for next internship, Agile project management, and then the conclusion. So the lessons that I've learned, I've had so many firsts in tangible AI, because I think I started learning Python, self-learning Python in March this year by myself. And I thought I was making progress. But when I started my internship with tangible AI, I quickly found out that I completely didn't know anything. So I started learning properly Git bash, the Git commands. It was really pretty alien to begin with for me. But then I managed to learn that, and then moved on to files and directories and actually following the right path. I think we spent almost 2 hours with Holtz trying to help me clean it up, so I can have a proper file path. And then I've learned also how to create files, folders, and Sublime Text Editor. I never really used it before. So I've learned that as well. And then I've also learned GitLab, creating repositories in GitLab, and also pushing to GitLab and pulling to GitLab, pulling from GitLab as well. So it's really been a big learning curve for me. And and then I've used Substack. I hadn't used it before. I'm just going to show you the article that I was able to create for conversational AI algorithms. I really passionate about this topic. I didn't even know initially that I hadn't had really initially about the word prosocial. So it was a big topic for me to really research deep into it, and to be able to help us as a society to really create prosocial systems that would benefit the society as a whole. I think one of the conversations that we had is that sometimes people are not aware of the decisions that they make. But if you bring a different perspective, you're able to create more diverse and more beneficial systems. So I really enjoyed writing that article. So that was really good for me. And then go back. And also I hadn't used Anaconda before. So I was able to learn how to create Jupyter notebooks. As you can see that this has been created in Jupyter Notebook. I really enjoyed learning how to do that, like adding links and this link and adding images as well. I've got a few more images. And another thing that I didn't know as well was that you could actually create adding out text for blind people. Like you can't really see it here, but if I double click on that, usually this square bracket is empty, but if you double click on that, it's able to read the text to a blind person, which I thought is really, really good. So I really enjoyed learning that as well. And then, so it's really been a big learning curve for me, and I hope to continuously learn and develop. And if I had more time, obviously besides getting ill, I'd have had like to have an in-depth knowledge of Python to really get more involved in data analytics and have a deeper understanding of machine learning modules, NLP techniques, and create more chatbots, as that's what I'm really passionate about. I did also create one of the Jupyter notebooks. I think we had an assignment, so I kind of started on this as well, uploading data frames and stuff. So I was really, really learning different things from scratch. And then, so after I got ill, I couldn't really do much, and has kindly offered that I could start my internship again. So kind of brainstorm different ideas. As I have a background in finance, I thought maybe possibly that's one area that I've been interested in, financial markets. So perhaps I could create a crypto board with my Python skills, or also create a program that can detect if countermedicines, over-the-counter medicines, are genuine or fake. I don't know how yet I'm going to do this, but I think with my Python skills, perhaps I'll be able to do that. And also maybe join Kalika. I really liked her chatbot as well. Maybe just join with her and support her to build or learn how she did it, a wellness or emotional health chatbot, and also get involved in data analytics. And I've seen some courses for Python and data science in DataQuest. So I thought it's all well and good in me wanting to do all those things, but I kind of really needed to get the fundamentals in place. So at the moment, just decided that, okay, let me kind of fine tune my Python skills and data science courses from DataQuest and then build on from there. And then I considered how would implement these. So I looked at the project management methodologies which big companies use, even small companies, one which is the waterfall approach, and another one is the Agile methodology. So I didn't want to just have a theoretical understanding of those methodologies. I wanted to practically implement them, the best approach into my learning and development for Python and data science. So just a brief overview of the waterfall methodology. This is more like a linear project management approach where stakeholders and customers gather together at the beginning of a project and then create a step-by-step plan so they can achieve an end goal. So the defining factor is that each stage must be completed before moving forward. As you can see, this is the software development life cycle. So with the waterfall approach, you have to go step by step until you get to the end, and there's usually like a fixed timeline. So I kind of just thought about it and then thought, okay, maybe if I implemented that same approach, I'd have dates and I'll have things that I need to focus on a step-by-step approach. And then I also looked at the Agile methodology, where this is an iterative approach where you deliver incremental value throughout the project lifecycle. And as you can see, you plan initially, you design, you develop, test, release, and feedback. So the good thing about this is that you produce a minimum viable product that can bring benefit to the company or to the users. So also for my own personal learning, I took stock of what I needed to learn, which are called ethics, like learn Python, SQL, data cleaning techniques, learn machine learning fundamentals, intermediate and advanced techniques. And then I thought I have to break them down into small tasks that I'm able to do every week, like learn variables, loops, conditional statements, and so forth, so that they can help me to build beneficial computer programs as I go along. So every time I have to test that, I have really learned that skill before I move on. If I've struggled with it, I have to go back and make sure that I have understood it. So that's the whole plan really for the next 10 weeks. And in conclusion, it's really been a great and challenging learning curve for me, besides being ill and everything. But I've really loved it. Just meeting great people, supportive community. And I just want to say thank you to Hawks and Tangible AI.
It's been such a pleasure. You've been so much fun to work with. You bring so much energy and creativity to everything you do. It's so much fun. Wonderful. So Connie, I listed Connie's Substack. I think I listed Greg's as well. If the rest of you could put your Twitter handle or Substack or LinkedIn link in the chat so others can contact you. You guys have done such a great job. I think you'll be flooded with people interested in what you've done and wanting to contact you in the future. So get your name out there, start to make a name for yourself. Really looking forward to what you guys do going forward with and I want to follow you as well on those social media channels. Yeah, see you, Copeland. Great to see you. Thank you for coming.
Thank you, everyone.
Thank you, everybody. Have a good evening. Night and morning.
Thank you.
Oh, Copeland, you haven't even gone yet on your presentation. Sorry. We have one more. Please hang around, everyone. We're not all done. Copeland, go for it. Just take, Connie, could you stop screen share? We need to, we're 10 minutes late and I've been remiss in my emceeing. I've been talking to you about what you've been doing all week, and I've forgotten that nobody else has heard about it. Go for it. We can't hear your audio if you're talking. Oh no, audio is not working for Copeland. We've had this trouble in the past. He has a big Linux server network, and he switches laptops every now and then. Okay, well, why don't you go through your slides, and maybe I'll talk to them in the chat, and you can chat in the chat as well, just to give people a brief overview of what your project is. I can actually verbalize most of what you're going to be showing us, and you can guide me with your chats. So he's Copeland's working on a project to build a command, a skill, and query to give you the pulse of the world, but it's going to be pro-social. It's not going to give you all the horrible news of the world or anything that's going to bring you down. It's going to be focused on actually trying to bring you mental well-being or mental health, in addition to keeping you informed. It's keeping you informed about those things that are good. Wow, I hadn't seen this before. He's put together a list of various news sources, and he was using mostly the Facebook API in order to gather these articles and posts. So he grabbed some of the more positive ones among those lists of news sources. I don't think you see Fox News or some of the ones that showed up a lot in the fake news data set. He's got the ones that he thinks are most helpful in terms of maintaining someone's mental health while keeping them informed. And he tried to predict whether a particular article was going to get particular reactions on Facebook, whether it's going to get the thumbs up or the frowny face or the angry face or the thumbs down. And he found one feature, it looks like, in his, I can't quite read what the feature was, that was highly correlated with one of the target variables that he was working on, trying to predict. And he looked at a lot of the scatter plots, and he was, let's see. And so he's created this regressor and he's figured out, use this package called JobLib to pickle it along with all the data that it needs and all the parameters it needs and all the libraries it needs. The whole pipeline can be incorporated into this object that can be then downloaded to the web. And he's sent me those files, and those are now being served up at a URL that he can then download to query whenever the user tries to run his skill. So similar to how we're doing BERT and others, he's just created his own model to do that work of classifying articles as to whether they're going to be likely elicit smiley faces and happiness from the user. He's given an example of some of the article HTML that he's going to be providing to the user, I guess, or links to these pages and articles, and some of the scores that they receive, perhaps. He's giving an overall score for how likely it is for the user to click on them. So he's using live feedback in sort of a reinforcement learning approach to periodic. It's not quite reinforcement learning. He's just retraining it often to predict which article the user's going to predict on, and then he's using that score. He's trying to predict that score, and then ranking the articles he presents to you according to that. In future work, I think he's going to try to get feedback on what the emotional state is of the user after having read the article. Not only how much time he's currently measuring how much time they spent looking at the article, but as a measure of how much they enjoyed it. So if they spend time on it, then it's probably a good one. They're being mindful about their reading, and it's thought-provoking. But in the future, he's going to also have a dialogue with inquiry to gauge what they're actually feeling, sort of like combining with Kalika's bot to kind of understand their emotional state and use that to help them in sort of a reinforcement learning approach boost their emotional well-being. Is that it? Okay, awesome. Great job, Copeland. I wish we could have heard your voice, but thank you for being committed to the difficulties and challenges of not having hardware manufacturers build drivers for open source operating systems, and instead being focused on profit. So thank you for being pro-social and your support of Linux, and giving us all news to make us happy. Really looking forward. So Vish is working on an API. So all of you who have created skills for qary, including Pulse and Life, and I think that's it for this semester. But those will be up on an API, a web API soon, where you'll be able to build front ends for it and actually have be able to send links to people to exercise your skills and have conversations with your bots. Really great talking to you all and seeing what amazing work. This has to be the most impressive set of projects that we've ever had at Tangible. So really, really appreciate it. Any questions for anyone? Any ideas for anyone? Wow, everybody's just stunned like me. Thank you all. Look forward to the next cohort. Of course, you can email me at engineering@tangibleai if you're interested in the internship. I'll send you a link to the application. If you'd like to get involved on a more informal basis, I'm happy to do that as well. In case you don't have 10 hours a week that you can dedicate to sort of an unpaid internship. Also, I guess that's it. We'll be starting up in a week and a half or a little over a week on the next internship. And we won't be taking very many students next quarter, so get your applications in soon. Have a great week.
Thank you.
Yeah, thanks for the presentations, everyone.
Thank you, everyone.
Thank you.
Oh yeah, I forgot to thank Ryan and Ted. Thank you guys for hosting us at SDML.
Yeah, it was a pleasure. I think we might have lost Ted on the way. He was afraid that his Zoom froze up.
Good. It's not just Linux machines that have trouble.
Yeah, exactly.
Windows has to be rebooted too.